Most people think you need a PhD or a master's degree to get a high-paying job in AI. They are wrong. I came from a background in film and 3D animation, zero computer science degree at the time, and within 4 months, I was building prediction models for the stock market. Today, companies like Apple, Google, and Netflix headhunt me without even applying. In this video, I'm going to break down the exact no-nonsense roadmap to becoming an AI engineer in 2026, even if you're starting from scratch. Let's talk about why AI engineering matters right now. So the thing is, it's the biggest wealth transfer happening at the moment right now. I know right now it seems that AI might be a trend, but AI is actually reshaping every single industry, from finance, healthcare, logistics, entertainment, anything you could think of, AI could be used for it. It doesn't necessarily have to be an AI company. It could be anything that a business could use that could actually optimize their systems. Companies pay builders, not talkers. So if you want to get like a 6-figure pay, they want people who are able to build a real system that actually solves real problems for them. The things that save time and money for them, and also generate money for them. And I'm not talking about just using ChatGPT. That's not enough. That's not going to get you a 6-figure salary. And the thing is, why most people start is because they think you need a PhD. The thing is, you don't have to be the smartest person in the room. You have to be the most useful. And if you're able to solve a real problem, become important. And important people get what they want. You're able to work remote. You have more freedom. I know more people are saying you have to come into the office, but the more useful you are to a company, the more like luxuries, the more leeway you have, the more you could actually call the shots and actually set how you actually want to work in the environment, as long as you're delivering what they need. Why a lot of people don't start is because they think they need a PhD to actually start, and they have to be a math whiz and they have to dream in calculus. The thing is, I would say, is ignore the naysayers. This is a myth in this day and age. You don't need a PhD and you don't have to be a genius. The main thing is competence that beats credentials. The main thing about that, and what I mean by that, is that if you could show and prove you are competent in the field to actually deliver results for that business, they'll actually want to hire you versus someone who has a long list of credentials and certifications and PhDs and degrees, but haven't actually delivered any real product, especially a product that's specific to their business. What I would suggest is learn just in time. In fact, even nowadays, even if you do get a degree, the way AI is moving and computer science and coding, it changes so fast that by the time a class comes out, they have to update it. They can't keep up to it. But when you learn just in time, you know the foundation of how things how work in general. And then when things change, you learn what's changed and what actually applies to the business. So nowadays, the main language of choice is Python. That's what, like, PyTorch is what to use, and all papers are written in that. Not to say that you can't use any other language if you don't know the coding language. Yes, it is possible to learn AI and ML and machine learning in those languages, but the de facto is everyone writes in Python, and you don't want to have an extra friction of converting your code that you see in Python into a language that you know. You don't need that extra friction. You need to get results. You want to show your competency. You need to move as fast as possible. So you learn in just in time only the math that you need at that time. So you don't necessarily need to know all of linear algebra. If the problem you're solving needs a certain amount of math, people don't care if you went and did a 4-year degree, or if you stayed up and watched YouTube at 2 a.m. to solve that problem, just for that math problem to get by and solve the bug, right? As I mentioned before, as a title, competence beats credentials. They want to show you could get results. Nobody cares how you actually got there, right? The results matters the most to the business, mainly because they're like, okay, that's great, but in our case, this is our data. Data lives in all over the place. We have it in emails. We have it in documents like PDFs. We have some things that are point of sales. Sometimes we forgot to put the date. Sometimes we're not consistent with the date. We have day, month, year. Sometimes it's month, day, year. How can you take all that data, organize it, and actually put it into a model so it actually makes sense? Because when we put it in ChatGPT, we don't know what to say. We don't know what's going on, and it doesn't give us any result. You want to show that you're able to take their messy data, organize it that's actually convenient or basically specific to them and their issues with it, and actually give meaningful results that's in the context of their business, right? The other thing is avoid broad roadmaps where you show, just general ideas like AI could be used for this, or like just demos. You want to be very specific and not jack of all trades. For example, if you want I specialize in a specific domain, especially if it's a domain you work in, because you know what the problem points are, and you can actually give the results because you know what success looks like in that. So, for example, if you're working for a local businesses, and they could be a landscaping company or a pool setup company during the season, when, let's say, landscaping or people want to set up their pools, they get a huge influx of people calling in, and they don't have the resources or the people to hire to answer all the phone calls. A solution for them, and they're not an AI company, but a solution for them is having an automated system that actually answers a call, that actually builds into their database, that has all the frequently asked questions, answers them, book it, and put it in their calendar, and then organizes and basically gives the calendar list to the people who is going to actually fulfill the needs for that business, landscaping, or pool or whatnot. And it organizes them, because what happens is when they don't have enough people, the phone lines might get busy, and then they lose jobs, and you lose potential clients, and people get angry with that. Having a solution and you build it for one, once you have that, you can take that solution, go to any other company and say, hey, I'm not a jack of all trades. I've built this solutions for this landscaping company. Your pool setup company is very similar. I could do that for you. And then you can specialize in that, or get a company or build it for a company that does that for them, right? Main thing you want to be is a focused sniper and say, hey, I know this business. I know how to solve this problem. I could focus on it and actually solve it for you guys. And here's my track record for it. They'll be more useful. They'll be more inclined to actually hire you because you showed real world application of AI to their problem in their specific business, as opposed to making another cat or dog detector that you see on pictures just by following basically a tutorial on YouTube. When you're starting out, here's the actual technical stack you should learn. Now, I wouldn't say you should start with C++. If you're going to learn it for the context of the company or business, you could learn it later. But at the beginning, Python is mandatory because this is the de facto language of AI. Of course, you can learn AI and build it with any language, but a lot of the frameworks and a lot of the papers already use things like PyTorch and NumPy for the data science stack, and all those things are already built into Python. If you use another language, you could have to reinvent the wheel or basically translate where frameworks already exist with it. So when starting out, have the less amount of friction. Of course, there are always exceptions to rules, but you only find out when you actually have a specific job on there and you're like, okay, well, I need to know C++, I need to learn R or whatever language at the time. But all these skills are transferable, and you don't want to have the extra overhead of like looking at a paper or looking at a framework that already works in Python and then translate to another language if everything, all the literature and all the documentation and all the examples are in Python. So learn that first, worry about transferring later as the job dictates that, right? And master the data science stack first. So this is always a non-negotiable. NumPy, which is basically if you know Python as a language, a lot of people say it's a lot easier language and it's very powerful and it's general. And the reason why people say like start using like C++ is because that is a lot more optimized, and you could actually start working with bigger data and memory management and deal with the resources a lot better. NumPy is actually built on C++, but is in Python. And basically when you want to do heavy math, especially matrix math and all the statistics and everything you're using for neural networks, Python and everything else, data science, even pandas, they use Python in the background. Or NumPy, sorry, I'm saying Python, but NumPy in the background. NumPy, if you ever learned before, if you ever in the academic world heard of MATLAB, that is like $1,000 program. That is kind of like the de facto that the math academics use to do heavy math. NumPy is very similar syntax, or the way it works is very similar, but it's free and it's powerful for it. And you need to know this. NumPy is mainly for the mathematical numerical calculation part of it, to deal with heavy data. Pandas is basically, think of it as just taking Excel sheets or CSV, comma separated values, which is, think of like tables like Excel sheets or Google Sheets, and putting it into Pandas basically so you could calculate it on there. This is very common because this is the most of the work is actually data cleaning. In fact, I would say like 8% of it is that when the actually algorithm, once you have the data, is kind of known because it's after like a decade of this, or so many papers, so many models that already exist. The hard part is actually curating, meaning getting the data from the companies, or in your real world scenario, cleaning it and putting it in a useful manner that you could actually use. Example, something as simple as the date that is not standardized. You could have day, month, year, or month, day, year. If you take the raw data and put it in, you probably get an error because it might be missing dates. It might be coming from different places, and you have to, sometimes it's written out. So you have to be able to clean the data, reformat it, and makes it consistent before you put it in the model. You have to prep the data. This is very common, so you have to know, you have to have this skill set. The other thing as well is that once you have this data and you actually start learning using the machine learning or AI part or neural networks part of this, I would say you start off with scikit-learn before you go into deep learning, building like deep neural networks using PyTorch or anything of the industry standard that uses like the heavy duty state-of-the-art work. Because in the real world and core business algorithms, the things about scikit-learn is basically it's another Python package. So if you use Python, you just use that. That's like a library you could use, scikit-learn. And part of that has all the classic algorithms and statistical models and things that you would build, like for example, linear regressions or random forests or things like that, right? These are known models. And what people don't know is that, let's say deep learning or AI or models, these more state-of-the-art models, people see that as flashy and they want to take that and put it on every problem. The reality is a lot of the core business problems are actually solvable just by using the classic algorithms, and scikit-learn have them already built in. So you don't have to build from scratch in Python. You just bring it in, use that like 1 or 2 lines of code, and it gives you the answer. And most of the time, just taking like a linear regression actually works. So the main things when you actually start is use the algorithms and then test it out as a baseline to see, does this actually answer the question? Does this solve the problem? If it does, it actually makes your job a lot easier because, hey, I solved this in just a few hours just setting this up. You give it to the business, they love you, that's great. They don't know what's happening under the hood. You don't have to go anything deeper. But then if it doesn't work, you build out the model and you're seeing it's not giving great results, then you're like, okay, now let's start going into deep learning. And like, let's start using the industry standard PyTorch and look at the papers or models that uses it and start using the more up-to-date models and see how well they perform. Because when we use the classic algorithms, they fall short here. But you always start with the basics and use that as a baseline. And if it works, which works a lot of the time for a lot of core businesses are not AI companies. You have to understand that. They want to use AI because they have legacy of decades of work of data that is not organized in any special way. And AI could definitely help them, but they don't know how to curate and clean the data. They don't know how to get insight from that data. And like I said, they're not AI companies. So people who are working just in like Excel sheets and just having data entries and keeping track of their transactions and their inventory and things like that, just using pandas, cleaning the data and using scikit-learn gives them, and just use linear regression, for example, just gives them all the insight they need. And that's it. There's no need to go and take like PyTorch, and it's like using like a sledgehammer to an ant at this point. If the basics actually work and give them the solution. So don't always go complicated, get the job done with the least amount of friction. And if it doesn't work, at least you have a baseline to know, okay, this has to do better than that, and move on, right? And even if you set all this stuff up, how do you actually deploy it? This is where the engineering part comes in, because, okay, you solve the problem, you have a model that works, whether it's using scikit-learn classic models, you just call it in, you don't have to build anything, or use PyTorch by implementing the latest models. Complicated or simple doesn't really matter. Once you have something working, how do you get it out there? This engineering skills is where, how do you package it up and bring it out? Use something like Docker, which is basically, you containerize it. Think of it as if you ever had the problem where you build something on your code, it works well on your computer, then you try to take it somewhere else or put on another computer or show other people, and it doesn't work. And you're like, oh, well, it worked on my computer. Having it in a Docker container, you're basically building it in kind of like a containerized computer that you could just take that copy and put it on someone else, and it has all the environment and everything set up, and it just works right there. That's why it's a standard. So learning how to use Docker really helps. And also Git and the Git flow mentality is how to actually version control or source control your code. How do you actually update your code keep track of it, revert back. And if you're working with a team, how do multiple people work in the same code base? There's an actual methodology of that, as opposed to just opening up like a notepad and writing your code and then saving it, and then you have to make a change, and then something breaks, and then you don't know what you're doing with it, how to go back because it worked before, how do you save it, how to keep your versions. There's Git solves that problem, or any source control solves that problem, and Git Flow, the methodology of actually how to work in a team and make updates and new features that align with what is the business goals. Very important to know. Remember, your background is your edge. Right now, if you try to just go and apply for AI, because everybody's saying they're an AI engineer, they know AI, but they just know ChatGPT and how to make prompts, right? So it's hard to distinguish how is the right person for the job, for the company that's hiring, because of like, how did they know if they could solve our problem? Well, your past career is actually your superpower, because if you have domain knowledge plus AI, you are the prime candidate, because like, oh, they know our specific domain because you worked at it. So you know what the pain points are, what the problems are, you know what their frustrations and how AI can actually solve it and actually make it faster, and what success is supposed to look like, right? You have very unique problem insight here that someone, even a PhD with high credentials and have years and years of school in AI, if they don't know anything, like let's say about the food or restaurant business, right? They have to learn that, or someone has to explain it to them. And a lot of nuance they don't get, because they're like, well, my model, the numbers look good. And you're like, yeah, but there's no sales, right? Which is the KPI they care about the most, right? So, or the metric they're looking at the most, right? You would know that if you were in that specific domain, if you have domain knowledge and you're combining that with AI. So whatever domain you're in, that's your superpower. That will actually make you cut out from the edge, basically from anyone else in this industry. So that's where you want to build where you came from. So if you're from healthcare, if you're from sales or finance, leverage the problems in there and actually showcase portfolios. Or if you work with a company, show that the problem you solve in those space. Or if you don't, build an AI solution for a real problem in these spaces. So when you actually demonstrate it or showcase to them your portfolio, they're like, yes, we need that solution. That's the exact same problem we have in our industry. You're gonna basically be the signal from the noise from anyone else, because they're like, yes, you actually get it, right? So this, again, this also shows that you're able to speak both language, because what people think is that, okay, I just know AI and I just want to go in and show all the tech jargon in AI for me to get the job. But no, you actually have to know the business side of it, because the business side is basically what is the business problem that you're trying to solve and how you're using AI to solve that, right? So you have to be able to speak in both as well. You want to become the unicorn candidate. You want to be able to show, I know AI, but I know your business, right? So skip the line, and that's how you get headhunted, because they're like, hey, this person's in our business and they know AI and they solve the same type of business problem. They're going to jump straight ahead of the line when they're looking at candidates and different resumes and different people applying. Here's a 3-month break into the industry roadmap here. So month 1, I would say you learn the foundation in data. So that is basically learning Python. And again, you want to learn and like be specific. You don't want to go down a rabbit hole of, okay, let's say 100 days of looking up coding, which is fine. But the thing is with that, you're going to go down and they start going down the rabbit hole and of YouTube tutorials of learning every little thing about Python, which you don't need to know every little thing about Python. Think of it like this. If you never played hockey before and you're like, okay, well, before I play hockey, I have to learn how to skate. And then you're just skating all the time and never actually playing hockey at some point or have a stopping date. You're never actually going to learn the context of an actual real hockey game. When is enough? You need to know just enough skating skills to be able to start playing hockey, and then assess, okay, well, if I'm missing certain things, go back and learn a little bit more skating to play at the level I need to play at for that case, right? That's going to be the same thing when you're coding, is that you want to learn enough Python to get by so you could actually go to the next part of like, you want to know enough Python to understand like pandas, and also because remember, pandas is one of the modules in Python where you could actually work with Excel sheets, and you need to know as well how to use NumPy. So learn enough to use those stuff and then move on, right? Because the main thing you want to do with this is that if, as long as you're able to do the data science part of things, which uses a framework called Awesome, I know it doesn't look like it's spelled like that, but that's the acronym. Obtain, scrub, explore, model, interpret. So when you get data this is the main framework you're going to be using when working with real data with companies, is that you have to obtain or basically curate the data from a company, obtain it wherever they live. It might, again, it might be in emails, it might be in documentations like PDFs, it might be on their POS or point of sale system. You have to pull those in, right? Once you get that, then you have to scrub it. I use the example of dates. Dates might be represented differently on each system. Some of them might have missing dates. Some of them have the dates day, month, year. Some of them have the month, day, year. Some of them have 4 digits for the year. Some of them has 2 digits. So you have to make sure they're consistent. Some of it spells it out. Some of them are numbers, like January or Jan instead of 01 or just 1 for the month. So you have to make sure you scrub it and make sure you format it so it can actually is consistent and deal with missing data. Once you have that, you're going to explore like what kind of insight you can get from that data. And then from that, you're going to be like, okay, what model could I use? Like, I mentioned before that you want to use like scikit-learn, because scikit-learn does have machine learning built into a lot of the classic models built in, so you don't have to code it yourself. Let's try linear regression. Does that work on that data? Does it make sense to work on that data? Does it give a good result? Is the result good enough that that's all I need to do? And if it is, then you interpret the data, that the results you get, what does it mean for the business in that business case that they're trying to solve, the solution they're looking for? Because at the end of the day, the businesses are hiring you. They don't know anything about AI or machine learning or data. They don't care either. They just want to know the results and tell them what the result is. What does it mean to them? Think of it as if you went to a mechanic and you know there's something wrong with your car. You want them to look at it and then at the end, fix it and or tell you what the problem is, but interpret what it means for you. At the end of the day, this is what it means. Is it something wrong with my brakes? Okay, that's why you're hearing this clinking sound. What are your recommendations? Do you need to replace it right now? It's like, okay, no, you're good for next month, but you have to change it by then, right? So they interpret the information for you to make an informed decision. That's your job as that, right? And so once you understand that basic stuff and you learn enough Python to do that and not go down the rabbit hole of like 100 days of just coding, month 2, you want to do like your first end-to-end project and you're working with real data sets. And I would say you start off with scikit-learn because they have a lot of the machine learning models and just classic algorithms just built in. And you want to mainly focus at this point the pipeline from going from end to end, getting something working from taking real world data, using the awesome framework to basically clean it and interpret it, and then go all the way to the end to get a result. Now, the things at this point is not really necessarily getting the accuracy, because when you first start something, you're not going to be great at it. So you're not going to hit a home run on your first swing, but you really want to get from the start and get all the way to the finish. So you're able to take real world data. That's going to be the start part. And at the end, you're actually getting output. So you could give the interpretation and giving your insight and what that data actually means. So you get that framework working. That's your baseline. And then if it's not that accurate, it's not that great, then you're going to start improving it. And a lot of times it's not that great either because you haven't implemented something, or maybe the scikit-learn classic algorithms don't really work as well, right? But once you have this pipeline set up, that's where month 3, where it actually is going to be very helpful, because that's where you start specializing in your portfolio to optimize these systems for your specific needs. So for example, if you're using just regular data and pandas and let's say scikit-learn and regression model works, that's good. But let's say in another specific field and all the classic models don't work in this case, this is be the part where, okay, we'll need something a little more industrial strength. Instead of scikit-learn, we're going to use PyTorch. And the PyTorch is the state-of-the-art, basically machine learning or deep learning framework that all the latest papers and latest models, the state-of-the-art is using. So instead of using scikit-learn, you're going to replace your model that's not that accurate, go back and replace it with real state-of-the-art models, the machine learning models, deep learning models, AI models to actually make this better. You're starting to become very specialized because you're creating a very specialized industrial strength model that's really tuned for a special case or a special business problem. And when you want to do that, you want to start picking a lane to focus on. You don't want to be general basically a generalist. You want to and say like, I know AI, like, I know how to solve this specific problem. You want to be a sniper, a focused sniper, right? So this is where you start picking a lane of, okay, I want to do, let's say, computer vision or natural language processing, or I want to be data analytics. And maybe this model, like, the awesome model works better for this case. But if you could start using computer vision, then you start have to dealing with more hardware stuff for like video and cameras and things like that, or natural language processing. You have to use LLMs, start dealing with that. This is where month 3, you're going to find out what is your higher level skill set to solve, right? And at the end of the day, once you solve this stuff, the most important thing as well is you could have the greatest model in the world. You could be the best person or solve a solution that people have, but if nobody knows about it, it's the same thing as not existent, right? So you want to be able to document your findings in your portfolio here and show the value of it, right? Basically, you want to document the business value. When I say the value is the business value, this is what the businesses try to optimize for. Most of the time, it's try to save money or make money of it or save time by doing so. You want to show that your solution actually does that. So you follow the 3-month roadmap. You started learning the foundational stuff. Then you start learning more of actually working out your portfolios and using AI and basically the basics of it, like say scikit-learn, to learn the classic algorithms and actually build pipelines from beginning to end. And then afterwards, you start using something a little more industrial strength like PyTorch and using later models in your actual industry to start working on real problems on that. So how do you actually get hired? So after like 3 months, I would say you have enough foundation and enough knowledge or to actually talk the lingo and show something significant that at that point, I would say start applying for jobs. And yes, you're going to be applying before you're actually feeling ready. One, because it takes a long time before people actually start replying. It's not like you reply and then 15 minutes later, everyone stops what they're doing and then reply back to you. And it's a numbers game, right? You're going to apply out there and most likely you're not going to hear anything. That's just how it works, right? So when you start applying for positions beforehand, before you're ready, by the time you feel a little more confident, then you're going to start getting feedback of all the applications that you put out there. And at that point, then you're going to see that as long as you're consistent, you're going to see that it seems like they're all coming out of nowhere, right? So what I would suggest is you wake up in the morning or whenever you do it. Just a lot of people I know when they're networking or they're looking for try to create opportunities, they block out like an hour a day and just apply to like 5 applications daily. Just go up, just apply, put it out there, and they go about their day. After a while, then you're going to, just a numbers game, you're going to get 1 back, 2 back, then at one point it's like an avalanche, right? On top of that, to compound all that, right, is that you're going to be also still working on your work and posting daily, right? Momentum beats perfection. You want to get in a routine where you're doing this, that you're doing a little at a time, but it builds up over time. When you look back on it, you're like, oh, wow, I achieved a lot, right? So the thing is as well about this is, of course, when people think of AI and getting into the industry, you're thinking of the big companies and like Google, or Apple, or whatnot, but every company needs AI. It doesn't have to be a tech company, right? There's a lot of basically hidden job markets that they even might not even post that they need AI to try to solve a solution that you happen to be able to solve it. Like there's a lot of old industry roles that the solution, they're actually looking for the solution. So again, this is where if you know the domain yourself and you know AI, you can actually apply to jobs that don't even have AI into it. But you say like, hey, I know you're trying to solve this problem. You reach out to them and say, I know how to solve this problem with my solution because either you worked in that domain or you learned about that because you hyper focus on that domain to solve. And you say, I know this is the pain points you have, and that's what this role is supposed to do. But I know AI, and this is how I actually could apply it to your solution. If you actually take the time to speak with me, I could tell you how it could be done, right? You want to basically pitch how you could bridge your skill sets. You know the domain, you know the pain point, you know how AI works, and how you could actually solve the problem and the benefit it is to them, right? The other thing I mentioned is earlier, while you're doing your 5 applications a day, while you're still building out a portfolio and learning more about AI, start building in public. What I mean by that is also post your daily, let's say on LinkedIn. I say LinkedIn mainly because that's where the business people are, as opposed to like posting on TikTok. Most likely they're not on that platform, right? So if you go in and you start learning, hey, I implemented a new PyTorch, the latest state-of-the-art model that's better than my last model, which used scikit-learn, and you showed it specific to a specific domain, and you just post that, right? Recruiters are lurking and notice things like that. If you do that consistently, again, you just put in your routine. Every day you apply for 5 applications. Every day you post something that's specific to your industry, specific to what you're learning, that recruiters are looking for, because they're trying to hire old roles. Or like, hey, we need someone to solve this. This person's daily posting something related to what we're doing, and they're consistent with it. Just we're posting 1 or 2 times. Don't expect you post it 1 time and then all of a sudden everyone stop what they're doing and they're gonna apply to you or reply to you or reach out to you. But if you post consistently, after a while, after a few weeks and whatnot, the recruiter keeps seeing this in their feed. They're like, you know what? Let me look into this person and let me just take a shot and reach out to them. That's literally how I got a lot of people reaching out to me, because of they've seen the things that I've done before, or that's related to that. They're like, hey, that's actually interesting. That might actually be what we need for this role. Let me just reach out because it's kind of unique and see if actually this could be a good fit. And that's when it's your chance to go and start pitching your skill set and how your skills, your domain knowledge, and your AI solution could actually bridge the gap between the skill sets, the domain, and actually how to get to the problem or the solution to the problem that they're having. I want to be clear. This plan is simple, but it's not easy. Yeah, all you really have to do is like learn Python, and then after learn a little bit of foundation stuff, and then start solving problems in domain. Sounds easy, but the reality is you're actually going to be going through a debugging pain. You could work on for 6 hours just to realize, oh, I missed a comma, especially if you're just starting out, right? It's going to be tiny mistakes, and I used to make that a lot for years, actually, when I was starting out, because it's not something that's innate to people, right? It's a muscle memory. The more you go through it, you're like, I know this is what I want to do, but it's not working. Why not? And to try to figure it out, right? The other thing as well, when you're looking at papers, like academic papers and using the latest models, they might feel like an alien language, but the more you do it, they better get at it, right? Remember that implementation beats theory. You don't have to know every single concept, understand every single thing in the paper. I don't understand everything because it's not required. You just need to know enough to code it. And especially nowadays, you don't even need to code in a lot of cases. Models already exist. You just have to know how to put it together, right? So, and like I said, if you're solving a business problem, a lot of businesses that needs a solution to their problem, they're not necessarily AI businesses. So you don't necessarily need the most state-of-the-art model for it to work. A lot of even the basic models work in their case. They just need the problem solved and they don't know how to put it together, right? Basically, you just need to know enough to put it together to solve their problem, right? You want to be the person who ships, right? And actually deploys a working model that has real impact, that say, hey, you put this out, it actually works. I literally spent over a decade working with PhDs. They could tell you every single math concept, write it down, the history of it, worked with the best people in the world, directly with the professors who wrote it, that Google hires them and they're writing all the state-of-the-art papers, right? But the thing is, they can't actually deploy a real model to save them their life. If the business say, could you make something that works in this context? They can't actually do it. They can show that they make the math and show you all the theory, but you need someone who actually able to do it. Think of it as, let's say you're like a race car driver, right? And you need the engineer and the mechanics and the engineers to actually build the car. They can tell you everything about the car. That is what a researcher is, because they're super important. They make it all work, but they can't actually drive the car. You need, when you're actually in the race, you need someone who knows actually how to handle it and work in a real world condition with real world constraints. In the race car example, you have a split second to figure out how to deal with a situation to win the race, and also take into account the weather conditions, your opponents, and all that. And also decision making of, well, there's no great choice, but which one do I solve and how do I mitigate the issues, right? That is a very different problem that you're solving, and that's what companies need, people who actually deploy it and actually make it work in the real world in messy conditions, and there's no red or there's no clear answer because you have to basically choose your heart or choose what's going to work best and mitigate it and interpret that information for the company so they understand it and they're okay with that. The thing is, when you have like PhDs, really, really important. Don't get me wrong, you need them. They're also the ones who are making blue sky and making new discoveries and moving it forward, right? But that is not their expertise. Taking real impact, making a decision that's not deterministic. Well, we have to solve this by tomorrow and we could only choose one issue and it's not a perfect solution, but how are we going to deal with it and how are we going to mitigate it, how are we going to deal with the clients, things like that. You want to be that person. That's where the value is. So the 2026 break into the industry roadmap, remember the 3-month plan is start off with the foundations, leverage your domain and actually build real pipelines at work and focus first on building the boring business solutions to their problems, right? Because most businesses are not necessarily AI powered companies. They just need a solution to it and you could have a real impact and they'll love you for it and you become really, really important and you get paid really well to solve problems that they couldn't solve without you.